In this video, we're going to have two main topics. The first one is how ancient chemists first started measuring pressure. And in the second part, we're going to talk about how to convert pressure units. First, let's talk about the first measuring pressure experiments. Way back in 1643, an Italian physicist named Torricelli came up with this cool device called a barometer. You've probably seen it in textbooks. It looks like an empty beaker that gets filled with mercury metal, which if you've never seen is really cool. Highly toxic, so don't eat it or anything. But it's this liquidy stuff, super dense, really excellent for these kinds of experiments because it'll climb up tubes as well. And what he did is he filled a tube, like a pretty tall tube, like probably taller than 80 centimeters of mercury inside of a tube. And then he inverted that tube and he put it inside of this vat of mercury. That way the tube was upside down. Now, if you didn't know anything about pressure or the fact that there's air in the world, then you would think that all of the mercury inside of this tube would fall out of the tube. But what he found is no matter how thick that tube was, there always was a little bit of space left over, but that the mercury itself would end up being about 760 millimeters of mercury tall every single time he did this experiment. The only way to explain this, knowing that there's a vacuum inside of this tube as the mercury metal falls down the tube, is that there must be some kind of force pushing on this liquid, making some of the mercury stay going up the tube. This is our first idea of what pressure is, thinking that the air or air molecules, or honestly, they didn't even have ideas of molecules back then, but just that this air, this fluid that we breathe all the time, that this stuff is pushing on the mercury metal, making some of it stay in the tube. This is also where we get one of our very first units of pressure. Millimeters mercury refers to how tall this tube or how high the mercury can climb at normal air pressures. We name this unit torr after the scientist Torricelli, who came up with the barometer, came up with this pressure measuring technique. There's also another piece of equipment called a manometer. Well, actually, I have no idea how you say that. It might be manometer. But it looks kind of like this. And the idea is that you would have some kind of gas providing a pressure inside of a tube, and then mercury metal in other parts of the tube. And then you could use a reading on a regular old barometer to figure out how much your air pressure is. And then you can use the height difference on a manometer to figure out what the pressure is on the gas. So let's say your gas pressure is a mystery, pressure of the gas. That would be equal to whatever the air pressure is, which seems to be bigger than the gas pressure right now. So I would say it would be the air pressure minus the millimeters mercury, the height of the mercury tube. Basically saying that my air is pushing harder than the gas is pushing by the H amount. And then that way we can figure out the pressure of the gas inside the manometer. You can also see another drawing of a manometer where you've got a gas that is providing more pressure than air, where you'd have a height difference that looks a little different. And this way we can see that the air pressure from outside is not as strong as the gas inside of the chamber. And that, in that case, you would switch around your equation. You would say, well, the pressure of the gas is bigger, so it must be whatever the air pressure is plus that millimeters mercury of the height difference of the two columns of the mercury. Now that we've talked about a few pressure measuring techniques from ancient times, let's get into how to convert pressure units. Before we can get started, we need to write down our set of equivalencies, or basically all the numbers we can set equal to each other in ratios to do all of our dimensional analysis. Okay, here are several of the most common pressure units that we have. Atmospheres is one of the chemist's favorite units. It's honestly really easy to mentally picture. It's the amount of pressure that you generally feel at sea level. So it's like, oh, okay, that's the air pressure. That's what I normally feel on my body. Millimeters mercury is that unit of pressure where we know that's how much air pressure can make a mercury column climb in a barometer. Kilopascals is a derivative of a physics unit for pressure. It's basically the newtons per square meter. It's kind of a weird unit, and it's honestly, you need a whole bunch of them to even equal an atmospheric pressure. So chemists don't usually use pascals, but in some of our equations, kilopascals are pretty useful. The International Union of Pure and Applied Chemists, which are pretty much the overlords of naming things in the chemical community, will often use bars to describe a pressure unit, and those are pretty much ATMs, so it's pretty easy to visualize them. And then we have this really awkward American unit of pounds per square inch. That's going to be your PSI. So if that's a little easier for you to see, PSI. That's what you're going to see on bike tires and car tires. Okay, so let's say that you've got a car tire that says that you can have 33.6 PSI on a good day. And you're really interested to see what that unit would be like in millimeters mercury. So you can take your equivalencies and say, okay, I want to make sure that my PSI unit ends up on the bottom part of my dimensional analysis and get 14.7 pounds per square inch PSI, and that's equal to 760 millimeters mercury. And then all we need to do for our dimensional analysis, just like in all of our other units, is multiply across the top and divide by the numbers on the bottom. This gets us some really fun number in our calculator. Let's see, 1,736 point a lot of change, and we'll round with sig figs in just a second. Wow, that's a whole bunch of things. Okay, so we started with 3 sig figs in this question, so we'll want to keep 3. We can either write this as 1,740 millimeters mercury, or you can be fun and use scientific notation, 1.74 times 10 to the 3 millimeters mercury. Most college chemistry textbooks won't even go through these kinds of calculations because they assume that you learned this part in high school. So make sure that you do a couple of these to feel really comfortable converting between the different pressure units. This will become extremely important when we use more advanced equations.